Welcome to this predicted paper from On Maths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our On Maths site. On Maths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For this question, it's really important that we understand what the words sum and product mean. Now, sum just means add, and product just means times. So we're going to start by adding the 5 and the 4. So that will equal 9. And then what we're going to do is find the product of 9 and 7. So we're going to multiply them together. 9 times 7, which is 63. So our answer is 63. So we've just got to know some vocab. Faces are where you could lay your hand flat on a shape. Then you've got edges where you can run your finger along. And then vertices are the corners, the bits that you would stab into your finger. So we've got 1, 2, 3, 4, 5 on the front, 6, 7, 8, 9, 10, including the back ones. There are 10 squares in total, so each square is worth 1/10. And if we count all of the shaded squares, we notice that in total there are 7 shaded squares. So that's 7 lots of 1/10, or 7/10. For us to create the smallest number, we need to pick the smallest digits at the start of the number. So the smallest digit is 3, then the next smallest digit is 4, next smallest digit is 5, then the next smallest digit is 8. But it wants it to be an odd number, and this is an even number. So we have to move that 8 forward 1 and have that 5 at the end. So the smallest odd number is 3,485. Whenever we multiply two negatives, we always get a positive, so we know our answer will be positive. We're going to do 9 times 12, which is going to be 108, and v times v, which is going to be v squared. So 55% is the same as 55 over 100. And what I can do is I can divide top one of the fraction by 5. And so that is going to equal 11 over 20. Now in total there are 20 squares here, because there's 5 across and 4 down. 5 times 4 is 20. And if there's 20 squares and we're looking to shade in 11/20ths, it's just going to be 11 squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Mode just means the most common or most frequent, and modal is exactly the same. It's just the most frequent amount of coins we're looking for. So the students who had 3 coins in their pockets came up 15 times. Students who had 4 coins in their pocket, well, there were 16 of them. There were 15 students who had 5 coins, 17 students who had 6 coins, and 12 students who had 7 coins. So the most frequent amount of coins a student has in their pocket will be 6, because it happens 17 times, which is more than any other amount of coins. To find the midpoint, we can use this simple formula. And we're going to start off by finding the midpoint for the x component. And the formula is just adding the 2 x coordinates and dividing by 2. So we're just going to add the 2 x coordinates together. So we've got 2 plus minus 1 divided by 2. And that's going to be 1/2, or 0.5. Could do the same thing for the y coordinates. And the formula is the same, but just with adding the y coordinates together and dividing by 2. So it's going to be -5 plus 2. All of that divided by 2. So that's going to be -3 over 2, or -1.5. So we're going to track the amount of eggs to make the amount of, or to make each amount of omelette. So 5 eggs makes 17 omelettes. And we're just going to find out how much is required, how many eggs is required to make 1 omelette. So we divide that by 17, divide both sides by 17. And so 1 omelette would be 0.294 blah 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 eggs. Next we want to see how many for 67 omelettes. And to get to 67 from 1 times 67, so do that to the amount of eggs, and we get 19.705 blah blah blah. Now you can't get 0.705 of an egg, we always round with eggs, and we always round upwards, because if you need 19.7, 19 won't be enough, so we need to pick 20 eggs. To get from the length of a square to the area, we square the length. To work backwards, what we do is we square root, because the inverse of square is square root. So we've got 196, and we're going to square root it to find the length. So we work out the square root of 196, which is what number times itself is 196. And you should learn them from 1 to 15, so you should know all of the square numbers from 1 to 15. So you should know that the answer is 14. So the length therefore is 14. So to work out what the perimeter is going to be the distance around the square. So if I draw a square out, we know that each of these lengths are 14. So it's just going to be 14 times 4, which will be 56. Let's rewrite this expression, but with a time sign in, so v times w squared. Now w squared just means times by itself, so we can rewrite that as v times w times w. Okay, so we know v is minus 10, so minus 10. And we know w is minus 4, so it's times minus 4 times minus 4. Okay, so when you multiply, it doesn't matter which order we do it. So what I'm going to do is I'm just going to do these ones first, and I'm going to ignore that times minus 4 at the end. So minus 10 times minus 4, that's a minus times a minus, which is a positive, 10 times 4, which is 40, times minus 4. Now we're going to do 40 times minus 4, so it's a positive times a negative, so that's going to be a negative. And 40 times 4, well, 4 times 4 is 16, so 40 times 4 is 160. So it's going to be minus 160. We're going to start off by finding what the multiplier will be. So we'll start off with 100%, and it's a decrease of 32.6%, so we're going to take that away. And that will leave the percentage as 67.4%. Next we need to convert that into a decimal. So we're going to divide it by 100, and that will make it into a multiplier. And the beauty about a multiplier is all we need to do is get the amount from the question, 486, and times it by the multiplier, and it will do all the hard work for us, and it will give us the answer of 327.56. Bearings questions are normally written as find the bearing of destination from a location. So you can see in this question here that the answer is 275. So the line they're taking it from is this line here, this north line, and they're looking at this bearing here. So we currently are at B, and we're looking at the angle of A. So it is find the bearing of A from B would be the question. So to draw a line of best fit, you want to make sure that roughly there's the same amount of data on top of your line and below your line. But if you think about it, this line here would work according to that rule. Clearly the line of best fit needs to go with the data. So I'm going to start it roughly here and then just draw a line going down like that. Now you might notice that sometimes, like say if I draw that, you might notice that we've got 1, 2, 2 below, maybe this one as well, 3 below, and then 1 on top. Don't worry too much if there's not a complete equal amount on top or below. What we mean is if it looks like that, that's clearly wrong because you've got all of the data below and obviously this one here. You want it roughly so that there's equal amounts at the top and bottom. But if you have it slightly off, so slightly down here or something, don't rub it out. It's chances are you'll get the mark. They're quite lenient when you draw lines of best fit. So to draw this graph, what we're going to do is just pick 3 points for our x values. So I'm going to start off with x equals -2 and feed that into the equation. So we've got y equals 0.5 times -2, take away 5. So half times 2 is just 1, and a positive times a negative is a negative. So it's going to be -1, take away 5, and -1, take away 5 is going to be -6. Then we'll do our next one, which is x equals 0. And let's just finish that one off actually. We'll put it into the table, so -6, and we'll plot it. So -2 and -6 would be here. Okay, continuing on with x equals 0, so it's going to be y equals 0.5 times 0, which is just going to be 0, take away 5. So it's just 0, take away 5, which is just -5. So 0 minus 5 will be slightly higher, about there. And our last one will be x equals 2. So we've got y equals 1/2 times 2, which will just equal 1, take away 5. So it'd be 1, take away 5, which would be -4. So -4. And so that will be here. Now, don't just draw in the line that we've got. You've got to draw in the whole thing. And it will look something like that. So no gaps at all. You've got to do it for the whole graph. So I started at -4 on the left, ended at 4 on the right, and just lined my ruler up with the 3 points we've worked out. So we've got to first of all work out how many parts there are altogether. So oil has 21 parts, vinegar has 5, so altogether there's 21 plus 5, which is 26 parts. Now how many of those parts are vinegar? Well, vinegar is the second one, so it's going to be this 5. So vinegar has 5 out of the 26 parts, or a fraction would be 5 over 26. Here we're given angles on a parallel line, and the first thing we do is find out what letter they follow. And so I just connect the parallel lines with the angles, and it makes a little C. So if you look, it makes a little C. And C are interior angles. Now interior angles are a bit weird because they add up to 180. So to find x, what we need to do is take 172 away from 180, which will obviously be 8 degrees. And so it's going to be 8 degrees, and the reason is interior angles. Now some teachers call it co-interior, some teachers call it allied angles. Either one of those three is absolutely fine, you'll get full marks for. For each of these options, try and construct in your head the triangles that would be made from these lengths. And I'm going to give an example for question D, or for option D. And I'm going to construct my triangle just with sticks. So we're going to start off with our first stick, which is 19 centimeters. Then we're going to do another stick, which is going to be 37 centimeters. And we've got one last stick, which is 61 centimeters. Now, looking at the first two sticks, the actual combined distance of them, so when we add them together, so be 19 centimeters plus 37 centimeters, is 56 centimeters. So that's the combined width of them. And you can see that that actually wouldn't be able to create a triangle if the third stick is 61 centimeters. So the side here could combine with this side. So we could move this whole stick here onto this side here, but we can't actually make a triangle with it because the two lengths that we've got won't ever reach the end bit here. They just won't ever reach that bit to be able to create the triangle. And I'm just going to put that back. So our answer is option D. So we know that the mean is the sum of numbers over the amount. But in this question, we're actually given what the mean is. We're given that that is 29. We're also given the fact that there are 4 cards, so we're given the amount. So what we can do is just get our lines in and solve this. So what we're going to do is just times both sides by 4. So we're going to do 29 times 4, which is 116. And so we know that the sum of the numbers will be 116. So all we need to do is to find the 4th card, is get that 116 and just take away the numbers that we know. And when we do that, we get the answer 26. Now you can easily check this by adding up 37, 26, 27 and 26 again, and then dividing it by 4, and you will get 29. So the only way of answering this question is to work out what these are as ordinary numbers. And so 7 times 10 to the power of 7 would be 7, 1, 2, 3, 4, 5, 6, 7. And 9 times 10 to the power of 4 would be 90,000, so that would be 9, 0, 0, 0, 0. And so we're just subtracting them like that. And so we'll get 6, 9, 9, 1, 0, 0, 0, 0. And obviously if this is on the calculator paper, just type it into your calculator. There are no tricks here. You can't do anything with the 7 and the 9. You're not subtracting powers or anything. You're just literally typing in what it says. And there's a button on the calculator like that you will need to use. So if you don't know what that is, ask your teacher or ask someone to help you out with that. So we're going to first of all work out where 9 is on the y-axis. Well, we've got 8 here and 10 here, so 9 will be halfway in between. And what we're going to do now is just draw a line across at 9, and then wait until it hits the line, and then we're going to draw a line down, and you can see here that x is 1. So our answer is that x equals 1. To find average speed, we do the total distance and we divide it by the total time. Now in this question we've got a bit of an issue because the question wants kilometers per hour, but the units are given to us in meters and minutes. So we just need to do some basic conversions. So 1080 meters is going to be 1.08 kilometers because there are 1,000 meters in a kilometer. So all we need to do is just divide the meters by 1,000. Minutes are a little bit trickier. To get from minutes to hours, all we need to do is divide by 60. And so when you divide that by 60, you get 0.2 hours. So we're going to put the kilometers at the top, 1.08. And we're going to divide that by the hours, which is 0.2.
When you do that, you get 5.4. So our answer to 2 decimal places will be 5.40. Whenever you have a one-digit number or a one decimal place number, but you're asked to round it to 2 decimal places, you should really put a 0 on the end, which is what we've done.
So we're given a right angled triangle here, and we're asked to find length AC, which is this length here, and we're given the 2 other lengths. So we're going to be using Pythagoras. Pythagoras involves us labelling the sides A, B and C, with C being the one opposite the right angle. And we know Pythagoras is A squared plus B squared equals C squared. Both A and B here are 4.9, so it'd be 4.9 squared plus 4.9 squared equals C squared. So we're going to add the 4.9 squareds together, and that will give us 48.020 blah blah blah. And here we're going to do a bit of solving. So we're going to square root both sides to find out what C is. So square root of 48.020 blah 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 is 6.929 blah blah blah. Rounded to 2 decimal places, this will be 6.93. If I start by drawing a number line, and we're going to put the 110 in the middle. Now I'm going to label the next one down and the next one up. It says to the nearest 10, so the next one down would be 100, and the next one up would be 120. Now we're interested in the cutoff, and the cutoff point is between the 2 numbers. Okay, so that's the cutoff point. If it goes above that cutoff point, it would have rounded to the next number up. So if the number was here, it would round to 120. If the number is on the cutoff point, which we can see is going to be 115, then we know it would round up. So we need to find the biggest number in this part here. So this part here, and it includes this line actually, so it includes this line. So all the numbers that would have rounded to 110 would have been 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, which would be here. But if it was 115, it would have rounded to 120. So 114 is the biggest number it could have been before rounding to 120. And we know it didn't round to 120 because in the question it says it's 110 to the nearest 10. So our answer is 114. So with each of these pools, try and imagine it being filled. So pool A, first of all, we've got water coming into it, and it's actually going to go quite quickly initially, and then it will hit a point at the end where actually it will go really quite slowly because it's a wider pool. So we would imagine that the graph for pool A would actually go quite quickly at the start, and then at the end it would go much slower. And that doesn't really describe, the red graph doesn't really describe that at all. So for pool B, we start off actually quite quickly because it's quite thin, and then we have a wider bit here, so it will go slower here, and then we go quickly again. So we need a graph that starts off quite quickly, then goes slowly, and then goes quickly. And the steeper the graph on our depth time graph, the faster it's filling up. And that red line doesn't really describe that either. Pool C, however, we can see it goes slowly at the start. And then because it's thinner, it will go quicker. So nice quickly. And then it will go slowly again. Well, that is a perfect description of the graph that we're given. So the graph we're given is definitely going to be for pool C. So we're given 21 to 4 is the ratio. And we're just going to have our lines in, because what we need to do is make the left hand side be 1. Okay. And to do that, for 21 I need to divide it by itself, divide it by 21, and we're going to do the same to the right hand side. So 21 divided by 21 is 1, perfect, that's what we wanted.
4 divided by 21 is 0.190 blah blah blah. It says it wants it to 2 decimal places, so it's going to be 1 to 0.19. The formula for the circumference of a circle is circumference equals pi times the diameter. In this question, we're given the fact that the circumference is 37.7, and we're asked to find the diameter. So if we put our lines in, all we need to do is divide both sides by pi. So we've got 37.7 divided by pi equals the diameter. And so that is, when you round, well, it's 12.00 blah blah blah. Round to the nearest integer, that would be 12 centimeters. And we can try it by typing in 12 times pi, and we get what would round to 37.7. When something gets to the power of 4, you times it by itself 4 times. So we're going to do that to the x cubed here. So we've got x cubed times x cubed times x cubed times x cubed. Now when two powers of the same base are multiplied together, you add the powers together. So here we can add the 3, the 3, the 3, and the 3. And that will give us x to the power of 12. Now there is a simple rule here that we can use. Whenever you've got a power on the inside of a bracket and a power on the outside of the bracket, all you need to do is multiply them together. 3 times 4, which is 12. So let's look through this question to see what information we're given and what information we're looking for. So we're given the acceleration is 13 meters per second squared. We're also given the distance is 19. And we're also given the end velocity, which is v, is 34. And we're looking for the initial velocity. So which of these formulae include a, s, v, and u? That's got a t in it, that's got a t in it, so it's going to be this one here. So let's write that out. V squared equals u squared plus 2as. So that would be 34 squared equals u squared, because that's what the one we're looking for, plus 2 times 13 times 19. Okay, so let's just work these parts out. And so we've got 2 times 13 times 19, which is what, 494. And it turns into a solving part, so we're just going to solve this. So the first thing I'm going to do is subtract 494 from both sides. And so we're left with 662 equals u squared. Then we're just going to square root both sides. And so square root of that is going to be 25.729 blah blah blah. And it says it wants it to 2 decimal places, so it's going to be 25.73. So I'm going to write the question out. So y equals x plus 15. And we're told that we want to make x the subject to the formula. Now what that means is we want x on its own. What's stopping x from being on its own? This plus 15. So to get rid of it, we do the inverse, the opposite of plus 15 to both sides. Take away 15. So we end up with having y minus 15 on the left-hand side, and we've got rid of the plus 15, so we've just got x on the right-hand side. So x is equal to y minus 15. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. So I'm going to write this question out a bit bigger, just so we've got a bit more room.
and we're asked to solve. So what we're going to do with this is we're actually going to start by putting our solving lines in, and we're going to try and figure out what we do to get x on its own. So we're going to start by subtracting 9 to both sides, and so that will leave us with the 10x squared on the left hand side and then 250 on the right. Then we're going to divide by 10 both sides. So we've got x squared equals 25. And then we're going to square root both sides. Now, this does give us 5, but it also gives us -5, because minus 5 times minus 5 is also 25. So our two solutions are 5 and -5. So here we can just draw in 2 extra lines, and we can see that it makes a right angled triangle. And we're asked to find the length of the line segment AB. So we're asked to find what this length here is going to be. And we know what the other lengths are. We know that this is 2 and this is 3. So we're going to be using Pythagoras. And Pythagoras, we start by labelling the sides A, B and C must be the one that's opposite the right angle. And so we know Pythagoras is a squared plus b squared equals c squared. A is 2, b is 3, and 2 squared plus 3 squared is going to be 13. And then we're just going to solve that by square rooting both sides. So the square root of 13 is 3.605 blah blah blah. And it asks it to 2 decimal places, so it's going to be 3.61. So angles on a point add up to 360, and we are given the values of the angles, but in terms of r. So we know that r plus 9r plus 20 will equal 360. So we've got an equation here we can solve. So first of all, let's add the r's together. And so that will be 10r plus 20 equals 360. Then we're going to subtract the 20 from both sides. So we have 10r equals 340. And then we're going to divide by 10 both sides. So we have r equals 34. So our answer is 34. So the formula we need here is that the sum of the interior angles is equal to the amount of sides, take away 2 times 180. So we know that the sum of the interior angles is 2160, and we're looking for what n is. So we're going to do a bit of solving. Not too difficult. We're going to divide by 180 both sides. And that will give us 12, and then we're going to add 2 both sides, and that would be 14. So the amount of sides is 14. To see if a number's in a sequence, we get the nth term and we get it equal to the number we think is in the sequence. And if the number is in the sequence, then we'll get a integer for n. If the number's not in the sequence, then we'll get a decimal. So we're just solving this now, and we're doing 135 take away 24, which is 111. And then we're going to divide both sides by 10, and you're probably already seeing the fact that it doesn't work exactly, because n is 11.1, which means that Prisha is wrong. 135 can't be in that sequence. So it's really important, first of all, we make clear about how we convert things. So if I've got a unit in kilometers and I want to convert it into meters, then we know we just times it by 1,000. So 2 kilometers is 2,000 meters. But if I have something in kilometers squared and I want to convert it into meters squared, I actually times it by 1,000 squared, which is 1,000 times 1,000. Okay, so I'm actually timesing it by not 1,000, but 1,000 squared, so that's another 3 zeros.
You can see here that that's 1 million, so we times it by 1 million. So 13 kilometers squared is going to be the 13, and then it's going to be times by 1 million. So 1, 2, 3, 1, 2, 3. So it's going to be 13 million. Now, it says here the farmer must pay 1 pence tax for every metre squared. So this is going to be 13 million metres squared. And so that's going to cost him or her 13 million pence. But the answer is going to be in pounds. So we just need to get rid of 2 of the zeros at the end. So it's going to be 13, 1, 2, 3, 4. So it's going to be £130,000. So factorise means to put it into a bracket. And it looks like it's a quadratic here, but it's actually just a linear factorising because we don't have a number term. So we're going to just use one bracket for this. And looking at these terms, I'm going to focus first on the numbers. So 20 and 30, I can divide both of those by 10. And that will leave 2 and 3. So that's the numbers done. Next I'm looking at the t terms. We've got t squared there and a t there. So we can divide out a t, but that will leave a t on the first term. And finally I'm going to look at the u, and there's just a u on both of them I can factorise out, and actually that just leaves nothing on the inside of the bracket. Now always when you do this, expand the bracket to check if you've made any mistakes. So I'm going to do smiles and rainbows. There's loads of different methods. So 10 times 2 is 20, t times t is t squared, and then the u, plus 10 times 3 is 30, times t times u. So we know we've got the right answer. So our answer is 10tu brackets 2t plus 3. The first thing we need to do is work out the area of the floor, and you'll notice that this is a trapezium. So with a trapezium, the formula is half a plus b times h, and a and b are the parallel sides, so these ones are the parallel sides, and the height is the one connecting the two bases, the two parallel sides. So we're going to start off by writing down the formula. So it'd be half a plus b h. So half times 2.8 plus 1.2 times 11. And when we do that, we get 22. So the area of the floor is 22 meters squared. And it says here that the tiles are sold in packs which cover 3 meters squared. So if each pack covers 3 meters squared, we're going to do 22 divided by 3, which will be 7.33 packs that we need. Now obviously you can't get 0.3 of a pack or 0.33 of a pack. So we're going to have to get 8 packs and just have some left over. So we'll need 8 packs in total. Okay, next thing we look at is the fact that the Jenny has a 25% discount. So we need to find out what 25% discount would do to the £18.60 for the tiles, or for the pack of tiles. And so what we're going to do is we're going to get the £18.60 and we're going to times it by 0.75. So we're just going to find 3/4 of it because she has a 25% discount, and that would be 1,395. So that's the tiles are going to cost £13.95. Now I've done this in pence and I've kind of muddled it together here, so really let's just go back because I've kind of done this in pence. So that would be 1,860 times 0.75, and so each pack will cost 1,395, and the reason we're doing this in pence is the answer needs to be given in pence, so I might as well just make that conversion now. And so it's going to be 8 lots of the 1,395 pence packs, which will cost in total
11,160 pence, or £111.60. But Jenny has £100 to spend, and we're asked how much extra does she need. So we're going to do the 11,160, take away the 10,000 pence that she has, which will give us 1,160 pence. So she needs to find £11.60 or 1,160 pence from somewhere. So for this question, we need to understand the different types of graphs from different functions. So if we have a reciprocal graph, it looks something like this and like this. It could be the other way around, and it could be distorted, but it basically goes down to a point along here. It goes to infinity, and it goes to infinity along a point over here, and obviously those positions could change. Then we've got a linear graph. A linear graph is just any straight line, so just any kind of straight line, either up or down, and this doesn't look like either of those. Then we've got a exponential graph. An exponential graph just starts really small and then just really increases like that and just keeps going up. And here we kind of have that, obviously the other way around, it starts going down, but here it's actually going up, so it can't be a reciprocal graph. So the graph that this is, or could be, is a quadratic graph, because it's a nice U shape. So if we carry this on, it could be a nice U shape. It could also be a cubic graph as well. So it could go up and then down and then up, and that's a cubic graph. But the most obvious one is a quadratic graph. So quadratic function. Something we know about rectangles is opposite sides are equal. So these two will be equal. And these two will be equal. And you notice now that we've got simultaneous equations. So what I'm going to do is get the coefficient of the y the same. And I'm going to do that by multiplying everything in the second equation by 3. So we get 6x plus 9y equals 123. And I'm just going to write in the first equation underneath, because with simultaneous equations we work downwards. Now looking at the signs, they are the same, and the s in same is the s in subtract. So we're going to subtract going downwards. We're just going to subtract going downwards. So 6x take away 3x is 3x. 9y take away 9y is nothing, which is good. That's what we need. And then 123 take away 93 is 30. We're going to get our solving lines in, and we're just going to divide by 3 both sides. So we've got x equals 10. So we know what x is, but we need to find out what y is. So what I'm going to do is I'm just going to pick one of the equations. I can pick the 2x plus 3y equals 41, and just substitute the value of x in. So 2 times, instead of x, it's times 10, plus 3y equals 41. So it would be 20 plus 3y equals 41. Get my solving lines in. And we're going to take away 20 both sides. So we've got 3y equals 21. And then we're going to divide by 3 both sides, if I don't run out of room. So y equals 7. So we've got x equals 10, y equals 7. Now I could check that with the first equation as well. So 3 times 10 is 30, 9 times 7 is 63, 30 plus 63 is 93. So we know we've got it right. To find the probability that James will read on both days, we start here, and we just draw down the read path, and then we go down the read path again. So the outcome here will be, well, will give us the probability that James will read and the read. And to work out what the total probability is, well, the first one says read on Saturday, so it'll be 11 over 13.
The second one is read on Sunday, so that would be 9/10. And the word and in probability means times. So we're going to do 11 times 9, which is 99, and 13 times 10, which is 130. So our answer will be 99/130. What I'm going to start off by doing is rearranging this equation so that it kind of matches this one. So I'm just going to write it down. And we want the n to be -2. So what I'm going to do is I'm just going to put my rearranging lines in, and we're just going to add 10 to both sides. Now, we've already got this line drawn for us on this graph. And so all we need to do is draw this line. So we've got y equals 10x squared plus 8x minus 2 drawn for us. We just need to draw this line, which is y equals 10, and see where they cross over to find the solutions. So y equals 10 will be all the way up at the top. Let's just make sure I get it nice. There we are. I need to move that up a little bit. There we are. And let's read off the values that gives us. So it comes down here, and it comes down here. So the values it comes down to are -1.6 and 0.8, and those are our solutions. We don't have to for this question, but it might be helpful to draw a Venn diagram for this. And we've got green and brown leaves, so we'll have green on the left and brown on the right. So green and brown. And we're told that there are 19 green and 15 brown and 6 that were not green and brown. So the only number we can put in is the 6 on the outside of the Venn diagram. We're told that 19 are green, but we don't know which, either they're in here or a bit of both. So what we can do is we can label the center X, and we can say that there are 19 take away X just green, because they could have been both green and brown. And for the brown we can do the same, so it'd be 15 minus X. And for the next step, we know that all of them together add up to 32, because it says in the question. So we're going to add all of these, the 19 minus X, the X, the 15 minus X, and the 6 together, and we know that equals 32. And let's get our solving lines in. So we've got minus X and minus X, so that's be a minus X. And we've got 19 plus 15 plus 6, which will be 40, equals 32. We're going to take away the 40 both sides. And we can just times by -1 both sides to make them both positive. So now we know X is 8, we can start filling in the Venn diagram. So it's 19 take away 8, which will be 11. X is 8, so we know that that's 8, and 15 take away 8, which is 7. So find the amount that were green and brown. We know it's going to be 8. I'm going to draw out the two triangles that we have here just separately, and so we can see a little bit clearer about what's going on. And it's actually good advice to actually draw them separately. And so here we've got AB, which is, if I get off that mode, 33 meters. And so this is AB. And this other triangle is ADE. Should probably have labelled that on. And we've got the 91 there, and we've got 13 there, and then we've got 147 here. I think that's all. And we're asked to find length AD. So the first thing to notice is that these triangles are similar. And the way we know is that this angle and this angle will be equal, because on the original diagram you can see that they make an F, which means they're corresponding because we've got the parallel sides. Same with these two angles, they're going to be corresponding for the same reason. And this top one is a shared angle, so they're going to be equal on both diagrams. When you've got two triangles that have equal angles, they're definitely similar, so one's an enlargement of the other. If they're similar, it means that we can find a scale factor. And so what I'm going to do is just find a scale factor between the 13 and the 91. To do that, we do the big number divided by the little number, and that gives us 7. So the scale factor is going to be 7. And we're going to work backwards with the scale factor, and we're looking for length AD, which is this length here. And so we're going to do this one, and we're going to times it by the scale factor. So times it by 7 to find out what the new length is. So 33 times 7 is 231. So the question asks us to go from A to C. So we're starting at A, going to C. Now it would be nice if we can go straight there. We don't know the name of that road. So we're going to have to go down this road first, and then up this road. So the first road is road A. So we're going to go down A. And then the second road is road B. So plus B. To work out the area of this sector, there is actually a nice little formula that we can use. And I'm just going to show you what the formula means. So the formula is going to be what fraction of the full circle do we have? Okay, so we're going to find out the fraction of the full circle we have, and then we're going to times that by the area of the circle. So to work out the fraction of the circle we have, we get the angle that we have in the sector, and we divide that by the total amount of angles in a circle, which is 360. Then we times that by the area of a circle, so pi r squared. Let's use that for our question. So the angle we have for this question is 57 times pi r. Now, to work out what r is, we just imagine the circle is whole. I'll do a badly drawn circle. And you can see here that this length here, this 5 centimeters, is the distance between the center of the circle and the circumference. So that is a radius. So it's going to be times 5 squared. Put that into your calculator and you'll get 12.435 blah blah blah. And it says it wants its 2 decimal places, so we round that to 12.44 centimeters squared. So in this question we've got a right angle triangle and it involves 2 lengths and an angle, so it's going to be a trigonometry question. So we're going to start by labelling the sides. So we've got the hypotenuse opposite the right angle, opposite is opposite the marked angle, and the adjacent is between the right angle and the marked angle. Now notice the opposite doesn't have a number or a letter next to it, so we're going to cross that out, we're not interested in that. We're next going to draw our triangles for SOHCAHTOA. So it'd be SOHCAHTOA. And we cross out the opposite, so we're not looking at a sine or tan, we're going to be looking at the cos. So it would be cos the angle, or cos x, equals a over h, and the angle is 37, so cos 37 equals 7.1 over x. Now whenever you're in this situation, and we're just going to put our solving lines in because we're going to be solving this next, if I can press the right button, there we go. And whenever you're in this situation, what you can do is swap the left hand side, it has to be the whole of the left hand side, with the x at the bottom. You can just swap those over, and effectively what we're doing is multiplying both sides by x and then dividing both sides by cos 37. So when we swap those over, we get x equals 7.1 over cos 37. When you type that into your calculator, just make sure you close the bracket. If when you type in cos it opens a bracket, make sure you close the bracket before you ask your calculator for the answer or press the equals button. and that would be 8.890 blah blah blah. And when you round that to 2 decimal places, it will be 8.89. So we've got a right angle triangle here, and we've got two lengths and an angle that are involved in the question. So that means we're going to be using trigonometry. And we're going to start by labelling the sides. The one opposite the right angle is the hypotenuse, the one opposite the marked angle is the opposite, and the one between the right angle and the marked angle is the adjacent. Now we're not using the adjacent here, so we're going to cross that out. And the next thing we're going to do is we're going to do our SOHCAHTOA triangles. And so SOH, SOHCAHTOA. Just right. Now, because we crossed out the H, we can cross out the triangles that have a H in. So we're left with SO, and SO is short for sine x equals O over H. And so writing that in, well, the angle is x, and the O is 1.5, and the H is 2.3. And let's get our solving lines in. And what we're going to do is we're going to do the opposite of sine both sides, so we get x sine sine. The opposite of sine is called the inverse sine, which looks like that. And you normally press the shift button on your calculator and then sine. So when you inverse sine 1.5 over 2.3, we get 40.705, blah, blah, blah. And 2 decimal places, which it asks us for, that would be 40.71 degrees. So there are 3 parts that we need to find the area of. We're going to start with the easiest bit first, this circle at the bottom here. Okay, so the circle area is just going to be pi times r squared, and the radius is given to us at the top, which is 9, so it's just going to be pi times 9 squared, and that would be 254.469 blah blah blah. Well, we could leave it as 81 pi. Next bit is the curved bit of the cylinder, so we're going to do the cylinder next. And it's just the curved bit, and the formula for that is 2 pi r h. So 2 times pi times the radius, which is 9, times the height, which is 30. And that will give us 1696.460 blah blah blah. And the last bit is this hemisphere here. And so let's do the hemisphere. And the formula for the area of a hemisphere, well, this full sphere is 4 times pi times r squared, but because it's a hemisphere, it's half of that. And so it'd be half times 4 times pi times the 9 squared, and that will give us 508.938. And so the final thing is to work out the total area, so total surface area. And we're just going to add up all these numbers together. So we add up the 254.469, the 1696.460, blah, 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 and the 508.938, blah, 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 blah. And we get 2,459.867, blah, blah, blah. Do make sure you show the examiner that you're adding these 3 here. I've not done that because it would waste a bit of time for a video, but make sure you write it down. It says it wants it to 2 decimal places, so that will be 2,459.87 centimeters squared. There are 2 shapes we need to find the volume of. There's this cylinder here and this hemisphere here. So we might as well start with this cylinder. And the formula for the volume is pi times r squared times height. So it's the radius is 9, so 9 squared times the height, which is 30.
And when we work that out, we get 7,634.070, blah, blah, blah. Next is the hemisphere. To find the volume of the hemisphere, well, the volume of a sphere is 4/3 times pi times r cubed. But because it's a hemisphere, we just times that by a half. So it's half times 4/3 times pi times r, which is the radius, which is 9 cubed. And that gives us 1,526.814, blah, blah, blah. And so the total volume is 7,634.070, blah, 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 plus the 1,526.814, blah, 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 which equals 9,160.884, blah, blah, blah. It says it wants it to 2 decimal places, so when we round that, we get 9,160.88. So in this question, we are told that the centre of enlargement is at 6,4. So let's just put across there. And what I'm going to do is just draw ray lines from the centre of enlargement, and we're just going to go through each of the corners of our shape A. And we're going to just check whether it goes through the corner of shape B, which it does on this one. Let's just keep going. Yeah, it does on this one. But it does not on this one. So it says find the coordinate of the vertex of shape B that is not correct. So the coordinate is this one here, and so that would be -4, 1. First thing I'm going to do is add these column vectors. So we're going to add the tops first, and then we're going to add the bottoms. So it's plus minus 14. And so at the top it would be -4. And 11 take away 14 is -3. Then I'm going to pick a point on my shape, and the the top one tells us how far right we're going. So we know we're going 4 to the left because it's obviously a negative. So we're going to go 1, 2, 3, 4. The bottom one tells us how far up we're going. Well, it's going to be down because it's a -3. So 1, 2, 3. And we can do that for each of the other points. So 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And when we've done that, we can join them all up with straight lines. And label the new shape B. You can complete a unique version of this paper by going to our OnMaths site. OnMaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.